Hey, let's try to get one more in today, I guess. Problem number 3. It's a law of cosines problem. That's what they're trying to give us. I think on one of the years they messed it up again and didn't do a law of cosines, but we'll look at that here in just a second. You set the law of cosines like that. Okay, so I've got it all set up for you. And now to get theta by itself, right, we got to subtract the 13 squared and the 20 squared first from 19 squared. So I'm going to go 19 squared minus 13 squared minus 20 squared. And then you could divide by this factor in front of the cosine of theta, right? So I'm going to divide by negative 2 times 13 times 20. And that's all going to equal the cosine of theta. So I don't know, maybe you want to put down this kind of law of cosines situation where you've got something like, c squared minus a squared minus b squared all over, negative 2 times a times b. That's equal to the cosine of c. So this is like my c angle right here, right? Or you can call it theta, whatever. And this is my c side over there. All right, so you notice how that all sets up like that. Now all I need to do is jam all that into Desmos and take the inverse cosine of it, right? So let's jump over here, and I'm going to type in inverse cosine first, and then I think I'll try to put my fraction in there and then go, 19 squared minus 13 squared. You guys know the rest of this, right? It's just easy, punch it all in. And just don't make any mistakes. Woo, I got to be in the denominator. Negative 2 times 13 times 20. And we can't see the answer because it's off the screen. So it's 66.4 degrees, right? Now, wait a minute. It says, what's the smallest angle and the largest angle? So they're messing with us a little bit. Dang it. I didn't need to find that one right away. So 64.4 degree or 66.4 right here, 66.4. I should have found the one across from the 20 first, right? Because that would be the largest one. This is the largest angle because it's across from the largest side. And this is the smallest one because it's across from the smallest side. But I don't know. You find one of these, and then you could add it to that and subtract from 180, and you got the other one, right? So whatever, you guys get the picture. I hope you got to use the law of cosines on problem number 3. Okay, so on this one, we're looking for this angle right here. So let's call that angle C. And I think what I'll do is I'll say the measure of angle C. We'll try out our little inverse cosine, right? We said inverse cosine of, well, let's just go back and look. I want to make sure I have that down right. Oh yeah, I just had the cosine of C, but it'd be the inverse cosine, right? Okay, so I hope I'm making that clear. So what was it? It was a big fraction, and it was the c squared, excuse me, 5.25 squared minus 3 squared minus 4 squared, all over the opposite of 2 times 3 times 4, right? So here we go. I need to change a few things in here, right? So we change that to 5.25 and so on and so on and so on. You get the picture, I hope. You're just going to put those numbers into Desmos here to get angle C. So this seems like a reasonable, straightforward problem. When they talk about this one being a rhombus and everything, you got to know what a rhombus is. All 4 sides equal. You got to know the diagonals bisect each other, and the diagonals bisect each other perpendicularly. So I'm not sure we need the law of cosines here. You got 22.5. Let's look and see. I mean, you might be able to use it, but I don't think it's necessarily needed. Because now we can use Pythagorean theorem to get this little length right down here, right? I'll call that x. So we got x squared plus 22.5 squared is equal to 30 squared. How do I know that? Because it's a right angle. The diagonals are perpendicular bisectors of each other. So you go ahead and do Pythagorean theorem, and then you could do, to get this angle, let's call it theta. You could go theta is equal to the inverse tangent of 22.5 divided by whatever you get up here for x, right? Okay, so I know I don't have two variables here because I will know what x is after I do Pythagorean theorem. Plug that in right there. And then you'd have this angle and just double it, because the diagonals bisect the angles as well. So it's a weird problem. Maybe they messed that one up as well. All right, I hope that makes sense. Thanks for watching my video on problem number 3.